another recording. So now we're going to be looking at the third part of our ideal gas law experiment. Again, looking at Charles's law, except this time in a more quantitative matter. So we're going to take our syringe and we're going to unseal it. And we're going to fill it with halfway with air. So we're going to pull until it's at the 5 milliliter mark from the bottom of our syringe meniscus. Here we go. So we have about 5 milliliters of air in our syringe. We're then going to cap and seal our syringe. Okay, and in the meantime, we're going to turn our thermometer on and we're going to let it sit in air and we'll record the temperature. We'll record the temperature of room temperature. So I've been letting, just to show, temperature is relatively constant. So room temperature is about 23.7 Celsius. So we'll need that for later. Now what we're going to do is we're going to take this fixed volume of gas and before we take our first volume reading, we're just going to push down gently on our syringe until it no longer pushes back. And then we're going to record the volume inside our syringe. So in this case, our initial volume looks to be about 4.2 milliliters. So we'll write that down. So that's our initial volume at room temperature, which is 23.8 degrees Celsius. So now what we're going to do is we're going to prep a styrofoam cup with ice water. So allow me one moment to prepare the ice water, and then we'll resume momentarily. Resume. So now we have prepared our sample of ice water. So I already placed my thermometer in the ice water. So if we want to record the temperature of this ice water, it's 5.2 degrees. Sorry. Let's wait for it to settle. It's 5.0 degrees Celsius. Now what we're going to do is we're going to take our syringe that is sealed, make sure it's sealed, and we're going to place and immerse the syringe, the gas in the syringe, into the ice water. And we're going to immerse it for approximately 3 to 5 minutes. Sorry, we don't have to go 3 to 5 minutes. Just about a minute should be enough looking at the lab manual. So we're continuing to keep our gas immersed inside our ice water. We know the temperature of our ice water. We'll record the temperature of the ice water at the end of our run as well, just for accuracy's sake. So we still have a few seconds to go before we've reached the minute mark. Okay, now what we're going to do is we're going to take our syringe out and we're going to push on the syringe until it doesn't, let's have it immerse. And you're going to push on the syringe. Until it stops, until it can't go down any further with gentle pushing. So now we're going to record the volume in the syringe. And in this case, let me just wipe off the, there we go. In this case, we have a volume of 3.8 milliliters. And then the temperature of our ice water in this case is 3.2 degrees Celsius. Okay, so we've done the ice water portion of this experiment. So now what we're going to do is we're going to take the same sealed syringe and we are going to place it in warm tap water. So allow me to prepare the warm tap water. Okay, so we now have our warm tap water. We're going to put our thermometer in the warm tap water. And what we're going to do is we're going to take our syringe and we're going to again immerse it in the warm tap water. For about 1 minute. And you may notice that the syringe barrel begins, the volume of gas inside the syringe begins to increase. So let's spend another 40 seconds leaving it immersed in our warm tap water, and then we'll record the temperature of our warm tap water at the end of this 1 minute period. Everything going okay? It's been 1 minute. So now what we're going to do is we're going to take our syringe out. We're going to gently push until it can't be pushed further. And now we're going to record the volume in the syringe. So in this case, we have a volume of about 4.5 milliliters. So about 4.5 milliliters for our volume at elevated temperatures. Okay, and the overall temperature of our gas in the syringe was equal to 55.8 degrees Celsius. So we have all the data we need to complete part 3 of our gas law experiments. Now, just as one last follow-up, just for you to take one last observation. Here is our Erlenmeyer flask from part 2 after it's been allowed to completely cool. So I'd like you to record your observations as this is important for part 2 of our gas law experiments. Again, both part 2 and part 3 of this experiment look at Charles's law, which is the relationship between the temperature of a gas and the volume of a gas. So now you have everything you need to complete your laboratory calculations and laboratory report. So what we'll do is we'll clean up our laboratory box setups, and then we will start and discuss the calculations for this laboratory.